The production of clean energy is an ever-growing concern for the planet, and China is taking a big step in that direction. Just recently, a new gigawatt-hour class sodium-ion battery production plant was established in the Chinese city of Fuyang. This plant marks an important milestone for China and the rest of the world, one that could potentially pave the way toward a more sustainable future. The age-old question of what if has been answered. China's all-new sodium-ion batteries have finally hit the market. What does this mean for the future of energy storage? Will this technology be able to revolutionize the way we think about power storage? How will these batteries affect sustainability efforts? And what new possibilities will they open? Could this be the start of a new era in renewable energy resources? Let's find out. Lithium-ion batteries are dominating the technology world. From mobile phones to laptops to electric vehicles, everything in the modern world is powered by lithium-ion batteries. But due to supply strain and safety concerns, scientists are eager to find alternatives that are cheaper, safer, and more durable than lithium-ion batteries. And more than anything, sodium-ion batteries have the potential to be the perfect alternative to lithium-ion batteries. Compared to lithium, sodium is 1,000 times more abundant, has an infinite supply, and is extracted and purified at a much lower cost. Sodium-ion cells are generally 20 to 40% less expensive on average. Sodium-ion batteries are also safer than lithium-ion batteries because they don't catch fire and are less sensitive to changes in temperature. When compared to lithium-ion, they have a minimal carbon footprint and minimal environmental impact. China is leading the way in the transition from lithium to sodium-ion batteries. The Three Gorges Company in China, known for the world's largest hydroelectric project, has joined up with other companies to open the largest facility in the world to produce sodium-ion batteries, which can be charged without the need for costly lithium. The first factory to produce sodium-ion batteries at a rate of 1 gigawatt-hour per year has begun operations in Fuyang in central China. The Three Gorges Company's two subsidiaries and the government of Fuyang are investing in a manufacturing facility run by Hina Battery, which makes sodium-ion batteries. The company said introducing the product was a significant step towards the industrialization of sodium-ion batteries and the advancement of the energy storage sector. Hina Battery was started in 2017, and its sodium-ion battery came out in the same year. It was announced on December 18, 2021 that Hina Battery would collaborate with two Three Gorges companies and the Fuyang Municipal Administration to construct the first commercially viable sodium-ion battery assembly plant. The line will have a total capacity of 5 gigawatt-hours and be constructed in two stages, with the first stage having a capacity of 1 gigawatt-hour and being finished on July 28, 2022. Current sodium-ion batteries from Hina Battery have a cycle life of 4,500 cycles and an energy density of 145 watt-hour per kilogram. Company goals are to increase sodium-ion batteries' energy density to between 180 and 200 watt-hour per kilogram and their life cycle to between 8,000 and 10,000 recharges. On the same day that the first product came off of Hina Battery's gigawatt-hour grade sodium-ion battery manufacturing line, General Manager Li Shujun said in a forum address that the company's Fuyang production line will be expanded to 3 to 5 gigawatt-hours in 2024. Sodium-ion batteries have been on charge for a long time now. Many battery manufacturing giants are shifting their focus to them as the future alternative to lithium-ion batteries. Jiana Energy, a Chinese startup developing sodium-ion battery materials, announced that Lightspeed China partners had invested millions of dollars in the company. Jiana Energy, located in Shenzhen, said the company plans to utilize the funds to increase its manufacturing capacity, hire more employees, and construct a prototype battery production line and research institution. After closing an angel round with Shunwei Capital in August, this marks Jiana Energy's second fundraising round in the previous 6 months. Nearly $14.7 million had been deposited into the company's bank account. Jiana Energy's primary focus is discovering and perfecting fundamental materials for sodium-ion batteries. The company said that it has received its first orders from smaller domestic power battery manufacturers and expects to begin full-scale manufacturing by the end of the first half of 2023. There are now fantastic possibilities made possible by battery chemistry, especially for China, which aspires to reach carbon neutrality by 2060, as it will reach its carbon dioxide emissions peak by 2030. Kaoyu Liang, the founder of Jiana Energy, claims that sodium-ion batteries have no resource constraints compared to lithium batteries. Lithium scarcity and price rises that have affected the new energy sector are expected to be resolved once sodium-ion batteries reach industrialization. Jiana Energy has announced that by the end of 2023, it'll start planning to construct a production line for battery cathode and anode materials with an annual output of 10,000 tons. The company also plans to integrate upstream and downstream resources in the industrial chain to advance the use of sodium-ion batteries in various applications. The Chinese-based world's largest battery manufacturer, CATL, is also focusing on sodium-ion batteries. CATL unveiled its first-generation sodium-ion battery on July 29, 2021, saying that the energy density of the cell alone has reached 160 watt-hours per kilogram, the highest of its kind in the world. But this year, CATL has made another breakthrough. They have developed an AB battery system solution, which consists of mixing and matching sodium-ion and lithium-ion batteries in a certain proportion, integrating them into one battery system, and controlling the various battery systems through the BMS precision algorithm. The solution provided by AB battery system can compensate for the sodium-ion battery's current lack of energy density, while also expanding the sodium-ion battery's benefits of high power and performance even when the temperature is low. The cost of this new battery is also way less. The combined cost of a hybrid pack of $40 per kilowatt-hour sodium-ion batteries and $80 per kilowatt-hour lithium iron phosphate batteries works out to $60 per kilowatt-hour. As a result, fixed storage sodium-ion battery applications will be able to attain capacity much more quickly. There are other benefits, like an energy density of up to 160 watt-hours per kilogram with up to 200 watt-hours per kilogram is expected in a few years. Fast charging up to 80% SOC in 15 minutes at room temperature, excellent thermal stability, excellent low-temperature performance at -20 degrees centigrade. The sodium-ion battery has a more than 90% capacity retention rate. But not just China is focused on shifting to sodium-ion batteries as a future energy source. Developments in this field are happening throughout the world. Recently, a group of researchers at Busan National University in Korea, led by Professor Seong-Geo Lee, used quinacridones as precursors to make carbonaceous sodium-ion battery anodes. Professor Lee said, organic pigments have a variety of structures and functional groups. As a result, they develop different thermal decomposition behaviors and microstructures. When used as a precursor for energy storage materials, pyrolyzed quinastrogens can greatly vary the performance of secondary batteries. Therefore, it is possible to implement a highly efficient battery by controlling the structure of organic pigments precursor. In their investigation, the scientists focused on 2,9-dimethyl quinacridone. The molecules are arranged in a parallel fashion, but at 600 degrees Celsius, it underwent pyrolysis or thermal decomposition, changing color from red to black with a char output of 61%. Next, an in-depth experimental examination was done to characterize the underlying pyrolysis process. 2,9-dimethyl quinacridone pyrolyzed at 600 degrees showed both high-rate capability and outstanding cycle stability when used as a sodium-ion battery anode. As a result of surface confinement and an increase in interlayer distance, the nitrogen and oxygen-containing groups contributed to even better battery storage. In conclusion, Professor Lee said, organic pigments such as quinacridrones can be used as anode materials in sodium-ion batteries. Given the high efficiency, they will provide an effective strategy for mass production of large-scale energy storage systems. This breakthrough will most likely solve the low energy density cyclability problem of sodium-ion batteries, which are the two areas in which lithium-ion batteries are ahead of sodium ones. For now, the question is, can sodium-ion batteries replace lithium-ion batteries anytime soon? In the technology business world, lithium-ion batteries and sodium-ion batteries are seen more as complements than alternatives. Sodium-ion batteries, with their relatively low energy density, are better suited for use in medium and low-speed electric cars and in large-scale energy storage. Cost-effective sodium-ion batteries are predicted to become an effective supplement to lithium-ion batteries, particularly in stationary energy storage, as the industry raises investment, the technology matures, and the industrial chain gradually improves. Optimistic growth is expected. Batteries must meet a number of criteria, the most prominent of which are increased storage capacity, accelerated charging, increased safety, and reduced cost. Despite the short-term inability to deliver on the increased capacity, sodium-ion batteries look promising. Currently, sodium-ion battery products will mainly be employed in application scenarios with power dissipation requirements of less than 150 watt-hours per kilogram, helping to mitigate the impact of the limitation of lithium resources on the development of energy storage batteries. The development of sodium-ion batteries is a process of self-breakthrough. Eventually, sodium-ion batteries will go head-to-head with lithium batteries, competing for market share and efficiency.